Welcome to this comprehensive guide on creating a persistent game save system in Unity 3D and Visual Studio, essential for any seamless gaming experience. This tutorial will walk you through the fundamental concepts and practical implementation steps, ensuring your players can always pick up right where they left off. A persistent save system allows players to store and retrieve crucial game data, such as player statistics, inventory, and overall game state, across multiple play sessions. This means that even after closing the game, all their progress, items, and achievements will be waiting for them upon their return. This functionality is crucial for player retention and providing a continuous, engaging experience, ensuring progress isn't lost when the game is closed. Without a reliable save system, players can become frustrated and abandon games, making it a cornerstone of modern game development. We'll explore various methods for saving and loading data, each with its own advantages and disadvantages, tailored for beginner game developers. We'll cover popular techniques like JSON serialization, binary serialization, and Unity's built-in player prefs, helping you choose the best approach for your project. Our tutorial will guide you step by step through implementing a robust save system using Unity 3D for game development and Visual Studio for coding. We'll demonstrate how to integrate these powerful tools to create a functional and efficient save mechanism for your games. First, let's define what data we need to save. This typically includes player attributes like health, score, and position, as well as inventory items and quest progress. Identifying all the critical data points is the initial and most important step in designing your save system. For player statistics, we'll create a C# class to encapsulate these variables, making them easy to manage and serialize. This structured approach ensures that all player-related data is organized and can be saved or loaded as a single, cohesive unit. Consider using data structures like lists or arrays for inventory management, allowing for dynamic addition and removal of items. For example, a list string could store item names, or a list inventory item could hold more complex item objects, adapting as players collect or use items. Game state can encompass various elements, from the current level to unlocked achievements and environmental changes. This includes everything from the time of day in a game world to the status of non-player characters and completed objectives, all contributing to the player's unique journey. A common and beginner-friendly method for saving data is serialization to JSON format, which is human-readable and widely supported. JSON's clear, text-based structure makes it easy to debug and understand, even for those new to data serialization. In Unity, we'll create a Save Manager script to handle the logic for both saving and loading our game data. This centralized script will act as the primary interface for all save and load operations, promoting clean code and easy maintenance. Inside Save Manager, we'll implement a save game method that takes our game data object, converts it to JSON, and writes it to a file. This method will orchestrate the entire saving process, from data preparation to file system interaction. The JSON utility class in Unity is perfect for serializing and deserializing simple C# objects to and from JSON. It efficiently handles the conversion of your custom data classes into JSON strings and vice versa, simplifying the serialization process significantly. For file paths, application.persistentDataPath is ideal as it provides a platform-independent location for persistent data. This ensures your save files are stored in a reliable and accessible location across different operating systems, such as Windows, Mac OS, or mobile devices. Next, we'll create a load game method that reads the JSON file, deserializes it back into our game data object, and applies it to the game. This method will reconstruct the game state exactly as it was when the player last saved, ensuring a seamless continuation of their experience. Remember to handle cases where a save file might not exist, preventing errors and ensuring a smooth user experience. Implementing checks like file exists allows your game to gracefully handle scenarios where no previous save data is found, perhaps by starting a new game or displaying an informative message. To trigger saving and loading, we can use UI buttons or specific game events, such as exiting the game or reaching a checkpoint. This provides players with clear control over when their progress is saved and loaded, enhancing their overall gameplay experience. Let's set up a simple UI in Unity with save and load buttons to demonstrate this interaction. These buttons will serve as direct triggers for our save game and load game methods, allowing us to test the functionality in a user-friendly manner. Attach the Save Manager script to an empty game object in your scene, making it accessible for other scripts and UI elements. This game object will act as a central hub for our save system, allowing other parts of the game to easily reference and interact with the Save Manager. Now, let's connect our UI buttons to the Save Game and Load Game methods within the Save Manager. By assigning these methods to the on-click events of our buttons, we establish a direct link between player input and our save/load functionality. For more complex data, consider using a custom data class that implements system, serializable to allow Unity's JSON utility to process it. This attribute is crucial for telling Unity how to convert your custom objects into a format that can be saved and loaded. This attribute tells Unity that the class can be converted into a format that can be stored or transmitted. Without system serializable, Unity's JSON utility would not know how to interpret the custom class's fields, leading to errors during serialization. Another method for saving is binary serialization, which can be more secure and efficient for larger datasets, though less human-readable. Binary files are often smaller and harder to tamper with directly, offering performance and security benefits. Binary serialization involves using binary formatter to convert objects directly into a stream of bytes. This process essentially takes the object's memory representation and writes it directly to a file, making it very efficient for complex data structures. However, binary formatter has security vulnerabilities and is generally discouraged in modern Unity development. Due to potential risks like deserialization attacks, it's recommended to explore safer alternatives for new projects, especially those handling sensitive data. For simpler data like settings or high scores, Unity's PlayerPrefs is a convenient option, storing data in key value pairs. It's an easy-to-use API for saving small amounts of data, such as player preferences, volume settings, or the highest score achieved. PlayerPrefs is easy to use, but not suitable for large or complex game data due to its limitations and lack of encryption. It stores data in a platform-specific manner, which can be less robust for critical game progress, and offers no built-in security features. When designing your save system, always consider data integrity. What happens if the game crashes during a save operation? Without proper precautions, a crash could lead to corrupted save files, causing players to lose all their progress. Implementing a temporary save file that is renamed upon successful completion can prevent data corruption. This technique ensures that the original save file remains intact until the new save is fully written and verified, minimizing the risk of data loss. Another tip is to version your save files. As your game evolves, your data structure might change, making older saves incompatible. Versioning allows you to manage these changes gracefully, preventing issues with players who have older save data. Including a version number in your save data allows you to write migration logic for older save files. This means you can detect an older save file and automatically update its structure to match the current game version, ensuring backward compatibility. Testing your save and load functionality rigorously is paramount. Save at different points, load, and verify all data. This includes testing various scenarios, such as saving after collecting items, completing quests, or reaching new areas, to ensure everything is correctly preserved. Consider edge cases like full storage, unexpected shutdowns, or corrupted files during your testing phase. Simulating these challenging conditions will help you identify and address potential vulnerabilities in your save system before they impact players. For advanced scenarios, you might explore cloud saving solutions, allowing players to access their progress from any device. Cloud saves offer immense convenience, enabling players to seamlessly switch between different platforms or devices without losing their game progress. Platforms like Steam, Google Play Games, and Apple Game Center offer built-in cloud save APIs. Integrating with these services can provide a robust and widely supported cloud saving solution for your game, leveraging existing infrastructure and user accounts. Remember to keep your save system modular. Separate the saving logic from your game logic for easier maintenance and updates. This architectural approach promotes code reusability and makes it simpler to modify or replace parts of your save system without affecting other game components. This modular approach ensures that changes to how you save data don't break core gameplay mechanics. For instance, if you decide to switch from JSON to a different serialization format, you can update only the save system module without needing to rewrite large portions of your game's core logic. Encrypting sensitive data, such as player passwords or personal information, is crucial for security, especially in online games. Even for offline games, protecting save files from tampering can prevent cheating and maintain game integrity. While JSON utility doesn't offer built-in encryption, you can encrypt the resulting JSON string before writing it to a file. This involves using cryptographic libraries to scramble the data, making it unreadable to unauthorized users and significantly enhancing security. This tutorial provides a solid foundation for implementing a persistent game save system in Unity 3D and Visual Studio. By understanding these principles and techniques, you're well equipped to build reliable save functionalities for your own game projects. By following these steps, beginner game developers can create robust and reliable save systems for their projects. This will not only improve the player experience, but also lay a strong groundwork for more complex game development challenges in the future. Experiment with different serialization methods and always prioritize thorough testing to ensure your player's progress is safe. A well-implemented and thoroughly tested save system is a hallmark of a professional and enjoyable gaming experience, building trust and loyalty with your player base.